All right, we're going to talk about web applications. But before I start, I'd like to make a short detour and tell you a story. So the year is 1996, and there's this company in Santa Clara, California, which is about to release the next big thing. And they called it like a desktop killer. So this isn't just a like a regular company. It's called Sun Microsystems. So it's a big CPU manufacturer. So it's a company that invented Java, actually. And yeah, they're releasing this thing. They're announcing it, and they're saying that it's going to kill the desktop computers. So the project was called the JavaStation, and they positioned it as a network computer. And what's cool about it is just this device that sits on your desktop. You can plug your keyboard, you can plug your display, and it doesn't have a hard drive, and it only has like a lightweight OS. Once this OS boots up, it runs a web browser. So yeah, it works like that. It starts the web browser. The whole operating system is written in Java. And basically, there's a web page. The only thing you can do is that you can use the browser, you can open web pages, and these are apps. These are actual apps that this computer provides. And in these apps, there is a Java applet, so like programs that can be run by a Java virtual machine. And they are actually quite rich, so rich applications that you can interact with. And these programs actually were quite smart. So this is an example of their word processor. Does it work? Yes, it works. So it's a word processor, and this runs entirely in the browser, as you can see. The JavaStation didn't have a hard drive. It was booting the operating system from the flash memory. And then also it didn't have, so the entire state of the app was also stored remotely. So for example, if you power it off, power it on again, everything will be everything will be saved. So the state is persisted. So this was really revolutionary, and this was really ahead of its time because it was even a year before the JavaScript was standardized. But unfortunately, the next big thing didn't happen, and it completely flopped. And Sun had to shut it down. And why it flopped? Well, basically there were lots of complaints from the users saying that it was slow. It was the support for HTML was not that good. The Java was a bit outdated. So like everyone complained that it's not really usable. So yes, Sun shut this project down, and then eventually in 2007, Sun was acquired by Oracle, and now this company doesn't exist anymore. So, but really, why did this project, why was it canceled? Well, I think to answer this question we should look at this concept called the innovation S-curve. So this is a model that kind of explains how the technology evolves. So basically, it starts slow when there is no foundation. Then there's like a period of rapid growth, and then there's like not a stagnation, but it's like a slower growth where everything is matured. And I think it's really important to use this model because that way we can predict when the technology is mature enough, and also we can explain why some technologies fail. And in the case of JavaStation, it was too early, so that's why it didn't lift off. So for me, the story of JavaStation is inspiring, even though it didn't happen. So now we have JavaScript. I find it inspiring because it really resembles how web development evolves, what is happening right now. So in this talk, I'm going to touch on some topics of what was happening in web development, where we are now, and where we are heading. And I'd like to start with this diagram that I did. It's like how we are as developers progressing, right? So essentially, there are three things that we are trying to optimize on. So first, there is like a user experience. And it describes if something like an app meets your expectations. So it does what you want it to do, and it does it fast. Then there's a developer experience, like how fast can you actually build this and ship this. And then finally, there's also like a limitation of the platform. So there are some things that are just not achievable. So that's why you cannot build them. And once you have the advancement in the platform, you can have better user experience, and after that, move to developer experience. So there are two outcomes. First, when the new tech comes out, people want more. And that's why these days you don't use disk phones. It's not, for you, it's not enough these days to have this user experience. The second thing is that when something new coming out, the tooling, the developing tooling is not there yet. So it's like, from the developer's perspective, it can be quite painful and quite slow. But I'd like to get back to the good old days. Let's say there's a person, right? There is a human, and there's a computer, right? Maybe it's in the same room. Yeah, it's in the same room. It's a personal computer. Maybe it's someone's bedroom, right? Maybe, well, in my case, it was the bedroom. Yeah, and things were really simple back then. Basically, you click, and then you get the result immediately, right? And computer was physically in the room with you. And we tend to think that programs back then were really like simple and outdated, but this is not true, because even if you look like 30 years ago, there were things like 3D rendering, like video games, all that stuff, and this is really exciting. And I will use this example of a desktop app. It's basically, let's say we're working on the app, which is like an app that allows you to save the collection of your plants, right? So it's a desktop app, right? So the way it works is that you choose a plant, you click on it, and then you can add it to your collection, right? And everything is instant. Everything is, well, I mean, it should be instant. Maybe your computer is not powerful enough, but it's fast enough. So it's good, but then the question is, what if your computer dies, right? What if it catches fire? What if it dies? All your data is gone. Or maybe, what if this computer isn't powerful enough? Or what if there's not enough knowledge on this computer? Maybe you want to collaborate with other people. So what we've done is we took our computer and we added another computer, right? So we put it somewhere out there, let's say San Francisco, right? So now this computer is really far away from the user. And in some way, right? Yeah, so now we have the browser, so we can send the HTML to the computer, and then in the browser, our users can interact with it. But in some way, it was a step back, right? Because we lost this interactivity, and the computer is not in the room with us anymore. So now there's like the features, like it's not as instant, as fast and as interactive as before. So then we started wondering, what if we take this computer, the server, and ask it to generate some HTML on the fly, right? So what if we use this common gateway interface, right? Use like some program, like even like C++, Perl, PHP, and generate this page just for you. So this is what CGI did, and in that sense, this computer becomes more personalized, and it becomes something that has the information which is intended just for you, right? So let's take a look at the user experience, right? So our plant app, first it takes some time to load the page, then the page loads. Maybe you remember these old days when everything was slow. Yeah, and then you can choose the plant, you click on that, and then you have to wait for the full page refresh, right? By the way, your browser is probably if you think about that, the browser is probably the most backward compatible app out there. So these websites still work. So if you use your browsers, you'll still be able to use them. And things like, like the blinking tag, I think it's gone. It's not there anymore. So as you can see, we got our first websites. But then we decided that, well, now we have to catch up. Now we have to improve on user experience that we lost. So we basically started adding JavaScript, like maybe some scripts to make it more interactive. And we basically realized that there are so many cool things that we can do with JavaScript. Of course, I skipped quite a lot of content here. But anyway, we realized that JavaScript is so powerful that now it is fast that we can, what if we just generate the entire HTML with JavaScript in the browser? Right? So this is what we did. So we basically take this HTML with a bunch of JavaScript. We then take this blank page, and then we render this HTML using JavaScript. And if you think about that, actually, our user is now a bit, well, it's not, I mean, it kind of moved away from the computer again, because this is what the user experience looked like, right? So the server responds with an empty page, right? Maybe with some placeholder. And then it takes some time to render the page in the browser. So there's some kind of delay. OK, so this was cool. But then we realized that it wasn't easy to build it. We needed some way, because if we wanted to build like bigger apps, we needed some way to do it faster. So this is why we started to work on tooling now. So this is how, and the reason we started working that is because JavaScript is now fast, and now there are more features like browser history API or Ajax prefetch, right? So now we have all these technologies, and now we can integrate on component-based view libraries, right? So we can make this single-page app experience more efficient. So let's take a look at the timeline, right? First, we got some basically like 2010, we had Angular Knockout Backbone, which they didn't even have their own template-like language. They recommended some libraries. And it was only like string-based. So you take something, you interpolate it, and then you get the HTML. Then React came out with this thing called VDOM, and it was really like, it was met with a lot of skepticism. So the idea is that your app is just one big function that produces like this JSX, and then there's like a virtual DOM under the hood, right? But I really wanted, we're going to get back to React, but I really would like to focus on Ember.js now. So it was 2011. And I think what they proposed for rendering was really innovative. So let's say we're working on this app, which is like a simulation of a light switch, right? So we can turn our light on and off, and then we want to turn the light off automatically after a certain timeout, right? So what we have is like we have this Boolean variable, then we have the status, then we want to render it somewhere on the page, right? And then we need to like, when it changes, we have to set the timeout and then turn it off, right? So Ember proposed this idea, and basically they suggested to use like so-called like a graph for that, and they proposed to use like a computed properties, templates, or Ember objects. So basically the idea is that you describe your app as a graph, and then you bind these values to your HTML, and then let's actually take a look at the code. I think it's better. Don't try to understand this code. It's just an example. And it's really outdated. So this code is over 10 years old. But just to give you the idea, this is like this Ember object with some state, some computed properties, and then like an observer that tracks changes to that property, right? And then there's a template. So what really introduced was really clever. Basically, you take these properties. You can see when they're changed. Then you build a graph. And then when they change, you only update parts of the HTML that you actually need, nothing else, right? So I think that was really ahead of its time. But unfortunately, no, well, you know, Ember is still around, but it's just, they have a really nice community. I was once an Ember.js developer, but it just, yeah, it didn't take off. But Ember is still there. Well, we quickly realized, we'll get back to this example, by the way. We quickly realized that this user experience of having like a flash of blank page with a single page apps is not a good experience, right? So again, it was like a step back from the CGI era, because now we don't see the page immediately once it loads. Now we have to wait more for it to be generated by the JavaScript, right? So we introduced this, how did we fix it? We introduced the concept of server-side rendering, right? So what if the server sends like a server-generated HTML, right? Then we are taking that HTML, we are making it interactive, and then done. You can use the app, right? So in some way, we kind of moved the user back, like it's still in the bedroom, but now it's like closer to the bigger computer. Yeah, but why did it happen? Well, because there was like a precursor. People started talking about isomorphic JavaScript. There was an article in 2011. This concept that, hey, JavaScript is now powerful, it's fast, and it can run on both browser and the server. So let's do this. Let's build this thing. So it was just a concept. So they didn't actually propose any solution. It was just an idea. And then if you look at React, actually, surprisingly, I was really surprised. The support for server-side rendering in React was in the first public version released. So yeah, I think that's really impressive. And then, unfortunately, Ember.js, Angular, they were quite late to the party. And again, this follows this S-curve. Now it can be explained, right? So React was there at the right time. It introduced server-side rendering when we needed that. But then Ember and Angular, yeah, they were late. So, okay, let's take a look at our plans app again. So let's say we have like this. The server sends the server-side rendered HTML, right? And then, but the page isn't interactive yet. Now we have to hydrate it. So this is the process of making sure the state that you have in the HTML is exactly the same as in your app. So it takes some time, it hydrates it, and now everything becomes interactive. You can start using the app, right? Well, it turns out that SSR was not easy. We had to spend a lot of time as developers to set it up. Some people had even like special like developers in their teams to just support the whole like bundling and the whole tooling behind it. So yeah, this is now we're here. We have the really nice improvement in user experience, and then we started to iterate on development experience, right? Developer experience. And there were some nice features already available, like dynamic import, or the NPM ecosystem was bigger. So we started to work on full stack frameworks, the frameworks that would simplify this process of getting your app SSR ready, right? And actually, we're still iterating on that. So if, as you can see, there are new frameworks that are coming out, SvelteKit, Qwik City, Remix, relatively new. There is a nice Remix community here in Copenhagen. Next.js, of course, and the reason these tools exist is because they solve these three problems. First of all, they provide file-based routing, right? So you basically can write faster. You can add more devs to your team. You can build bigger apps. Then you have SSR set up, of course, and then finally they also provide some recommended tooling, so you don't have to spend time on like agreeing what tool you should use for linting and predefine your code. But this is what is happening now. Several other developments were taking place. The web development market was growing fast, and now our users are now becoming greedy, right? They're saying, well, now my standards are high. I want more from web apps. I want them to be like faster, like smarter and stuff. And that resulted in like bigger JavaScript bundles, more execution of JavaScript, right? And basically increased rendering per page. So you have to, like your computer has to spend more resources on rendering. And we started noticing, we as developers started noticing two issues. The first one is the performances of re-rendering. And this is like how fast our apps can react to like some updates, right? And that is actually quite related to the INP, Core Web Vitals metric, interaction to next paint. The second problem was the performance of hydration. So as you have seen before, there is this brief moment when your app becomes interactive, and that was also like with some bigger apps that became an issue. So let's take a look at our human-computer diagram. So the server provides server-side rendered HTML. Our smaller computer hydrates it and makes it interactive. Then our users start to interact with the page, and then the app re-renders, and only after that it's ready, right? So these are bottlenecks, and as you can see now, they're not like we're moving them away again, which is not what we want. So let's talk about re-rendering first. Unfortunately, and luckily, I don't have enough time to speak about like how rendering works. But let's take, for example, Virtual DOM. Basically, what happens is there's like a tree of your components, and when something happens, your app has to re-render everything, like basically following that tree, right? But I think it's better to see using this illustrated example. Basically, let's say you have an app and you want to collect this plant, right? So by the way, the only reason why your app can re-render in Virtual DOM libraries is because a state of one of its component changes. That's the only reason, if you think about that. Even if you use context, that's just state of the components, right? So we click on connect, there's like an event happening. Oh yeah, sorry, wrong slide. This one, yeah. So this is how it's supposed to work, right? Yeah, so we click, and now we collect. Good. The explanation is here. So there's like a user event that results in state change, and then your app starts to like re-render everything, basically building the new virtual DOM. Once it's ready, it starts to compare it with the previous virtual DOM, and then it tries to find differences, and once it finds differences, it updates the DOM. It's called reconciliation, right? There's a nice article that I will give you a link at the end of my talk, but anyway, there's a nice article that explains more deeply how rendering in React works. So how do we solve these issues with re-rendering? Well, the technique number one that we, as developers, came up with is to have this so-called compile time reactivity. So the idea is that what if instead of like doing virtual DOM, we just take our code and we compile it at the build time, and then we transform it into like just native, like real plain JavaScript of like take this DOM node and update it when something happens, right? So Svelte uses that solid, which is more like has like a similar to React API, but it's different. Then the second technique is React concurrent mode. So the idea of the concurrent mode is that, okay, let's say we're still doing the full like re-render, but because it's heavy, we're gonna just split it in chunks of work, and then in between we're gonna take breaks, like we did today, right? And that it's like it works sort of like a CPU scheduler. So you can, it's still slow, but you still have time to do something else in between. That's React concurrent mode. And now there's like, most recently there's React compiler, which is like, okay, there is still React, there is still virtual DOM. We're still gonna re-render everything, but we're gonna analyze your code. We're gonna find some pieces that are not efficient. We're gonna optimize them for you. We're gonna cache it aggressively. And finally, I think this is, I'm particularly really excited about that. This is signals. This is not a new thing, actually. And signals is like this idea that you have like primitives of like a signal, computed value, and something that happens. And then you kind of bind it to the HTML. I think most recently, Svelte 5 introduced runes. Really cool. I've tried it recently. Works super nice. Preact signals is also really nice. There are two libraries for React, Jota and Nana stores, which are more minimalistic, but you can use them to have signals in React. Unfortunately, you cannot use Preact signals in React without like transpilation, but yeah. Solid has signals, and then there's also RxJS, which is a bit different, but then Angular used them back in 2016. So just to give you a quick example of how signals work, basically, let's take the light switch example. There's like a signal, computed value based on this signal, and then there's something that happens when this signal changes, right? So this is an example in Preact, and as you can see, I don't know if you can see my, oh yeah, there is a mouse. Anyway, you have to use like dot value to notify that this thing indeed changes. And Preact is smart enough so it can track dependencies. You don't have to specify them explicitly. And now there's like runes in Svelte 5, which is like, it's almost identical as you can see. The only difference is that here you don't have to use values anymore. It's really smart, so it kind of detects when you set it. You can just work with it as you would work with just regular variables. But you would say, wait a minute. This isn't new. I've seen it before. And yes, you'll be right, because this is the exact same diagram. This is the same idea that Ember.js invented. And in fact, yes, Ember did come up with signals. But if we go back to our S-curve again, here's what happened. Ember.js was too early, so we just didn't have the right foundation. We didn't have the right tooling. There was no, like, classes were not there. We didn't have a proxy API that Svelte uses these days. And now there is signals, and now, I'm not trying to say that you shouldn't care about signals. I think it's a pretty nice technology, but I think this helps you to understand why certain technologies just don't get the right adoption. So let's go back to the second issue, is the slow hydration, right? So it's the process of using client-side JavaScript to add interactivity to the HTML that we got from the server. And there are two techniques. So the first one is this idea that, okay, maybe we don't even, before we even hydrate the app, maybe it can even work without JavaScript at all, or with just a little JavaScript, right? And the second thing is called partial hydration. The idea is different, is that what if not all parts of our app are equally dynamic, right? Let's first talk about progressive enhancement. So this is an example from Remix. Shout out to Remix community. So this is like an example of a color scheme switch, right? And as you can see, this is just plain HTML, and this will work even without JavaScript, because it's just a form submit. But then once your app gets hydrated, then it becomes interactive, and then it can work more efficiently with just state changes and maybe with some fetch. So you don't have to do the full page refresh. So now I'd like to talk about partial hydration. Let's get back to our diagram. Basically, the idea is that what if these things like the sidebar, the top bar, maybe they don't change that often. Maybe they're don't have to be interactive. So this is what happens. We define some areas that need to be interactive, like this one and that one, and everything else we skip. So this is essentially how partial hydration works, right? So the timeline is that React Server Components, Next.js, right? It's essentially progressive hydration, or Astra has islands. Qwik is really cool, I think, because they have this concept of resumability. So there's like, no, we're not going to do hydration at all, no hydration. And Hona with client components, which is similar to React Server Components, right? So, okay, but I just want to touch on another concept which I think is also essential for the history of web development. So we were trying to get as close to our computer as possible, but here's an issue. Our big server is still in San Francisco. And yeah, it's close, but then this takes 700 milliseconds to get the response. So this is not a good user experience. So we started wondering, what if we take a new computer, and put it in between? Basically, this computer will live in the same city, or maybe even, I don't know, data center. Yeah. And then this is how serverless JS on the edge was born. So this is not a new thing. CDNs were around for quite a long time. And then, yeah, basically, this was an improvement of user experience, right? And then we figured that there are so many runtimes now, there are so many options that we need some way to deal with that complexity. And that's why we needed to interact on the developer experience. And this is how the concept of multi-runtime was born. Just going to give you some examples of, they have this motto of write once, deploy anywhere, right? So Remix, I think, is doing a really good job. It can run in different runtimes on the edge, on your server, etc. Honor is a multi-runtime web server, really fast. I think now the author works for Cloudflare. SSD, interesting. Yeah, really interesting approach. But anyway, now before I run out of time, I just want to talk a little bit about what's training now. I think the first thing I want to talk about is what's training now is all-in-one tool chains. So basically the idea is that what if we take all that complexity and we introduce just one tooling for everything? And there are some exciting projects like Biome or OXC recently by the Vite team. So there's still not everything is supported, but the idea is that we take the bundler, test runner, prettyfire, everything, and just recommend one tool. But then there's quite an interesting thing about, there are two things actually. Well, backend first or no build community, which is actively being, yeah, Rails community talks about it a lot. DHH, the creator of Rails, who is, by the way, Danish, he talks about it a lot. And then there's this concept. Recently, there's been some discussion about leaving the cloud, Versal things, so just have your own infrastructure. These are crazy ideas, you might say, but I think that there's a really nice explanation. Actually, I see it as a protest, right? So this is not different from the musical subcultures in the 70s and the 80s that were results of big economic changes, right? So I think that's the same happening. It's a protest of all the complexity that we have now, all the variety of tools that we have. And now there are people who are saying, first, we don't trust the cloud anymore. Give us back the ownership. And then there's also people who say, no, we don't want to build anything. What if we what if we just don't transpile at all, right? And there's this no build community. And this concept of ownership isn't, I think it also related to this new thing called local first. So the idea is that what if we want to take the ownership of the data as users? There's a nice article that gives an introduction to Ink and Switch, but let's move on. Basically, yes, we have our computer. Maybe it's in the edge data center, and we have the database, but it's still really slow because we have to talk to that database. Local first says that what if we basically take that database and put it here? So the computer is now again closer to the user, right? And I think it's here just at the right time because now we have all the exciting APIs. We have WASM, we have file system APIs, and we have CRDT. So real theory behind that, and we have WebSockets, so which is nice. Just some projects. There's going to be links at the end, but anyway, Local First Web Dev podcast. They had a first conference this year, really exciting. Some frameworks, some businesses, and also really interesting Postgres in the browser or vector databases in the browser. Really exciting. Anyway. Closing thoughts. What is going to happen next? Well, there's one thing that we cannot ignore, the big elephant in the room, and that is AI, right? I didn't want to mention it, but it's there. So the question is where is AI going to live, right? Is it going to live here? Is it going to be, maybe it's going to live somewhere here on the edge, or maybe it's going to be on your computer, right? Well, right now, the current state of things is that, yes, it is possible to have AI in your browser. There are some exciting projects with WebGPU. There is an upcoming web neural network standard. There's going to be links. I promise you. There's going to be. Oh, yeah, the QR code, yes. Anyway, the vector database for RAG. There's window.ai now, like an experiment. Web Stable Diffusion, Transformers.js. Yeah, here's just some demos. Yeah, so this is on the left-hand side. This is like a llama running completely in the browser, and this is like a game that uses Transformers.js to recognize objects. So you have to basically draw an object, and AI tries to guess what this object is. Also, check out this thing, which is like, it was released just maybe a week ago. It's a playlist of by Google of Web AI Summit, where they just talk entirely about like AI in the browser. And finally, one of the takeaways is that I think AI is well, there's still some models that cannot be run entirely on the client. It's heavy. So what we're going to see is we're going to probably see some hybrid approach first, when AI is maybe here in your room, but maybe with some bigger models is somewhere there. So there's a really nice and inspiring article about that with like lots of nice examples. Anyway, I'm sorry about going over time, but just want to end on a slightly personal note. 3 years ago, I was burned out. I was transitioning from hands-on coding. I was feeling outdated. I was feeling that I was rusty. So yeah, I took some time off, and I started to like relearn web development. One of the things was like actually coming to these events and seeing like what people use and what people talk about. I took some time off and I started learning. And you know what? I feel excited about the web again. It's a really interesting point in time where we are at now. And I think it's not just me. Actually, I feel like some people in the room maybe have similar feelings, right? Maybe questions like, am I being replaced by AI? Am I becoming outdated? So the purpose of my talk was to show you that, well, first of all, no. Second of all, so that you can see the bigger picture and understand that all the new things that are coming out also have some reflections from the past. Yeah. Just a final note, there's like that's the QR code with all the links, right? The big document. And I just want to also like mention my friend who did all these illustrations for this talk. Thank you. Yeah. I'm just going to wait for everyone to. Yes, thank you. There's some behind the scenes. Do we have time for Q&A or no Q&A?